Welcome to this explainer. Today, we're diving into what's literally the defining software architectural shift of 2026, the massive transition from passive chatbots to autonomous AI agents. If you've been following the tech space, you know the buzz is deafening right now. But today, we're going to cut right through all that noise. We're looking directly at the blueprints of how these systems are actually being built, coordinated, and secured in enterprise environments as we speak.
Let's kick things off with a stat that's honestly a bit mind-blowing. Gartner is predicting that by the end of this year, 40% of enterprise applications are going to feature task-specific AI agents. Just think about that for a second. We're up from less than 5% just a year ago in 2025. This isn't some slow, gradual adoption curve. This is a vertical climb. And these aren't just little helper bots either. They're integrated entities actively executing workflows across ops, finance, customer service, you name it.
And, well, the money absolutely backs this up. Looking at Roots analysis, the global AI agents market is projected to just explode. We're talking a jump from $15 billion right now in 2026 to a massive $221 billion by 2035. That's a compound annual growth rate of nearly 35%. The reason for this? Organizations are finally realizing that moving from human-prompted actions to autonomous agent-driven digital assembly lines is hands down the largest productivity unlock of the decade.
So, here's our roadmap for this explainer. We're going to cover the AI agent boom, the shift from tools to actors, multi-agent coordination patterns, the common language protocols making it all work, and finally, the agent cybersecurity threat.
All right, let's jump into part one, from tools to actors, the paradigm shift.
The biggest thing you need to internalize right now is that the era of the simple prompt, it's totally over. We are fundamentally moving from software as a passive tool to software as an autonomous actor. You know, a tool's predictable, right? It just sits there waiting for you to click a button or type a command. But an actor? An actor has goals. It runs complex end-to-end digital assembly lines. It's actually deciding which steps to take, which databases to hit up, and which other systems to engage, all semi-autonomously. It's literally the difference between handing someone a hammer and hiring a master carpenter.
Moving on to part two, multi-agent coordination patterns. Let's look at the architecture of autonomy.
So what happens when you have multiple agents working together across different enterprise departments? Atlan mapped out 3 distinct coordination patterns for this. First, you've got the supervisor pattern. This is where one central orchestrator routes the tasks. It's super clean, sure, but that supervisor becomes a single point of failure. Then you have peer-to-peer, where agents collaborate directly with each other. It's awesome for flexibility, but man, it creates a massive tracing gap if something breaks. And lastly, hierarchical. This is great for massive recursive tasks, but a bad instruction at the very top can totally poison the entire tree down below. The big takeaway here, you absolutely have to match your pattern to the task structure before you write a single line of orchestration code.
Because here's exactly what happens if you don't. Think about it. Regardless of your setup, if your finance agent and your sales agent are operating on totally different definitions for the word revenue, the whole system just falls apart. Finance might be looking at strict GAAP accounting rules, while sales is just using general booking dates. Suddenly, the supervisor gets 2 completely different numbers, and you've got absolute chaos. A multi-agent system absolutely requires a shared, governed enterprise context layer, so every agent is speaking the exact same business language at inference time.
Which brings us to part 3. The common language protocols are universal translators. To avoid that kind of chaos we just talked about, the industry has rapidly adopted some standard protocols over the last year to help these systems actually talk to external resources and to each other. First up is MCP, or the Model Context Protocol. Think of it like a universal adapter. Instead of your engineering team writing custom integration code for every single database or SaaS app, MCP acts as this standardized bridge. It gives your AI agents secure, instant access to your static enterprise data exactly when they need it.
And running right alongside that is Google's A2A protocol. So if MCP connects agents to data, A2A connects agents to other agents. It uses standard HTTP and JSON to provide a common language so agents can securely discover each other's capabilities, negotiate, and delegate tasks as peers. The best part? It's an open standard, so it works no matter what framework the agents were originally built on. It's basically the Internet Protocol, but for autonomous AI workers. Really cool stuff.
But of course, we have to talk about the risks. Part 4, the agent cybersecurity threat, the reality of autonomous actors. As we give these systems way more autonomy and interconnectivity, we hit the most urgent challenge of 2026, cybersecurity.
There's this great quote from Mike Gazzo, the Chief Product and Technology Officer at Ada, where he points out that securing an actor is a fundamentally different problem than securing a tool. Traditional, rule-based security assumes things are predictable, but agentic behavior, it's non-deterministic by nature. You give an agent a goal, but you aren't scripting every single step it takes to get there. Because they act on our behalf, we need completely new ways to protect ourselves.
Because these agents are out there optimizing for outcomes, they open up some pretty terrifying new attack vectors. We're talking about goal misalignment, where an agent basically does the wrong thing for the right reasons, or prompt injection, where an attacker sneaks in and overrides the agent's core instructions. Then there's credential compromise and memory poisoning, where a bad document inside a RAG system secretly manipulates the agent's logic. And because these agents are all chained together now via protocols like A2A, a single compromised identity can cause cascading failures across your entire digital assembly line way faster than a human operator could ever catch it.
So, how do we safely deploy these things? Security leaders have to adopt this rigorous three-stage framework. Step 1 is visibility. You can't secure what you don't know exists, right? You need a strict inventory of every single agent in your environment. Step 2 is configuration. We have to move past passive monitoring and set explicit, action-level boundaries so we know exactly what an agent is allowed to touch. And Step 3 is runtime protection. Real-time anomaly detection with human-in-the-loop triggers for the high-stakes decisions. The goal here isn't to kill their autonomy. It's to make that autonomy actually trustworthy.
Which leaves us with one final major thought. By the end of this year, non-human agentic identities are expected to top 45 billion. That means they are going to outnumber the human global workforce 12-1. The tech is here, the protocols are standardized, and the market is absolutely booming. So the question you really need to take away from this explainer is this. As we hand over the keys to these autonomous actors, how is your organization going to ensure that this incredible power stays fully governed, secure, and actually aligned with your real goals?